Good evening everyone, I am Mohammed Yusuf, a final year computer science student at Cambridge Institute of Technology. Today I am here to present my bus transport intelligence platform, which provides the travel time, estimates the delay risk, and also suggests optimal connected routes when there is no direct route available. So I began with extracting the dataset from Kaggle and did data analysis. These are the libraries which I imported for my analysis part. Here I imported my CSV file, and these are the top 5 rows which contain these columns. Here we can see that my dataset contains approximate of 36,000 rows and 8 columns, and most of the columns are of object and only one is of int type. And this is the mean median of the distance, which the distance delta, which is in int format. Here we can find out the average route distance is about 400 kilometers with the maximum of 3000 kilometers. Here the duration column, which was stored in object format, I had to convert it into int format, so I applied this function to convert it into number values. Next, here again the departure time and arrival time was in object format containing AM and PM. So I had to remove that AM and PM and convert that object value into numerical value, and this function does that. And here we can see the number of buses which are departing at different timelines in the 24 hours. Next, I created a column called speed kilometer per hour by calculating the distance and duration minutes of each operator. Then I tried to find any duplicate values and I found none. Then I tried to find missing values and there were no missing values in my data set. And even I tried to check with the null values in what columns did I created, and even there were no missing values in that. I also tried to check by inserting these null values in the string format whether this is in my dataset, and even this was not in my dataset. Next, I tried to remove the impossible values such as the distance cannot be negative, and duration of minutes cannot be negative, and speed per kilometer and cannot be more than 120. So I found these impossible values. So these have been removed from my data set. Next is the visualization. Here I have plotted a graph of distance versus number of trips. Here we can observe that the number of trips are more when the distance is of approx 300 kilometers to 600 kilometers. This is the distance and duration trip and duration minutes. So the longest duration or the longest number of trips are between 800 to 900 minutes. Here is the speed distribution, which says the most of the buses are of average speed of 35 to 50 kilometers per hour. And this is a graph which shows that the most number of trips departure are happening in the night, and most of the arrival of the bus trips is happening in the morning. These are the top bus operators which have approximate 2,500 to 3,000 bus routes connected to different cities. And this is the correlation matrix. Here we can see that the distance and duration minutes are strongly related, because the longer the distance, the longer the duration minute, and the lesser the distance and lesser the duration minute. Similarly, for speed and duration of minutes, this is weakly related, because the speed consists of multiple factors like traffic and multiple bus stops. So we cannot judge the duration of a bus by just considering speed as a feature. Next, this shows the most number of buses used in different trips. Here is the classification models, where I divided the departure time into, where the departure time is less than 12 hours, we will return it as a morning. Our departure time is less than 17, return it as afternoon. Less than 10 p.m., return it as evening, else night. So I have categorized into 4 columns. Here I selected them as features, and I divided my data set 80% for the training part and rest of the 20% for testing. And I scaled the data set for the classification models. First is the logistic regression. Here I got an accuracy of 55%, and the features which I took, logistic regression showed that most of 96% of my data is evening, which clearly says that logistic regression is being biased. So we move on to the next model, which is k nearest neighbor, which provides the same accuracy, but here we can see that the percentage of evening is 74% and afternoon and morning is 22% and 15%, which is slightly better than logistic regression. Next is the decision tree, which provides 59% accuracy, better than the previous two. And here we can observe that afternoon's percentage has slightly decreased, evenings has increased, and morning's percentage has decreased drastically, which also states that it's still being biased. Next is the random forest. In this I got the accuracy of 58%. Here the distribution of the percentage of the features is similar to what we had got in KNN. Next is the support vector machine. Here I got the accuracy of 59%, and we can observe that the afternoon percentage and the morning percentage has drastically decreased. So next is the comparison of performance of the models. Here we can see that the average of all these is approx 55 to 56%. So I did similar classification considering different features rather than afternoon, evening, night. Here I use the features like luxury, sleeper, economy and standard, and I found this same accuracy like 44. Here you can see logistic regression is being biased for luxury, and here the accuracy of decision tree is 46%, and random forest accuracy is of 49%. Then for the neural networks, I took labels of 0 and 1, where the 0 indicates the buses which have got delayed. The bus's average speed, which is less than 35 kilometers per hour, is considered as delayed, and the bus average speed, which is more than 35 kilometers, is considered as on time. So keeping these two labels, I activated the hidden layers, which I used 32 and number of hidden layers and also 16 number of hidden layers, and sigmoid for binary classification. After then I used Adam optimizer for optimizing the data. After training the data, I got an accuracy of 99%. Then these are the number of buses which are on time, and these are the number of buses which have been delayed. So this is my final data set after all the additional columns. So I used this data set and created a front end. So this is my front end, which gives an overview of the data set which I have, that consists of approximate 36,000 rows, average duration, average delay risk, active operators, highest root risk, then cities, number of cities connected, and the most reliable operator. Then prediction. So let us start our journey from Bangalore to Chennai. I have integrated Gemini API, so it gives a brief summary of the route and also why this route has been selected, and also it gives travel tips and risk analysis. And here you can see the comparison of duration of Google Maps and what my bus platform intelligence suggested. So Google Maps tells that it takes around 6 hours, approximate 7 hours, while one of the fastest route from my data set says that it requires 4 hours. And these are the available operators. And I have also integrated Google Maps so that it shows you the point of from and to. And this is the peak departure hour for this route. Here you can see the most number of buses departing are from 10 p.m. Now let us consider a journey where there is no direct route. Something like Bangalore to Bhubaneswar. Since there is no direct route, the Gemini API suggests that it takes approximately 35 hours to 36 hours to go from Bangalore and reach Bhubaneswar. Since there is no direct journey data set, so using graphs breadth first search, I can optimize the connected cities from which the user can reach early. So these are the suggestions. One is from Bangalore to Hyderabad, Hyderabad to Nagpur, Nagpur to Raipur, and Raipur to Bhubaneswar. Similarly, second suggestion, but this suggestion says it takes 38 hours. And here you can see the location in the maps. Then coming to the operators, these are the top 10 operators which are reliable and which have less number of delay risks. Next is the route. These are the most common routes, most number of routes used. Next is the network graph. This shows that Bangalore is connected to more than 5,700 cities. Mumbai is connected to approximately 3,000 cities. Next is the comparison of different models that have used. So this is the comparison of KNN and all the other graphs, which compares the R square score and the feature importance. The column which have contributed more to this model is the distance column, which is very much required and very much important for my project. So I end my project demonstration here. Thank you.